All right, today we're going to be working with radical inequalities. Now, yesterday we did radical equations, and so we're going to do the second part of that, which is solve inequalities containing radicals. Now, little different steps here, just to try to confuse you, as always. So let me go through the different steps. If the index of the root is even, which is all the ones that we're going to be doing today, if it's odd, actually you can skip the first step. But if the index of the root is even, identify the values of the variable for which the radicand is non-negative. Step 2, we're going to solve the inequality algebraically, just like what we did yesterday. And then step 3 is we're going to have to test some values. We're going to have a number line, and we're going to have different sections on our number line that we're going to have to go ahead and test values. Typically, we will be testing 3 values to see whether or not different sections work. And most of that comes from this part up here, because when we're taking the square root of a negative number, we get imaginary. And so that's why we have to worry about it being even. If it's odd, then it's not negative, so we don't have to worry about that then. So let's go ahead and take a look at this problem. So the square root of 3x minus 6 plus 4 is less than or equal to 7. So we do have that less than or equal to as opposed to just an equal to, and that's going to cause us a little more problems. So the first thing we have to do is we have to test to see when this value here becomes negative. So what we have to go ahead and do is we have to just solve this part, the 3x minus 6 equals 0. Greater than or equal to 0, so we'll keep it positive, but same basic idea, right? 3x is greater than 6, x and 2. X is greater than or equal to 2. We add 6 over, divide by 3. All right, now we also have to solve this. So we're going to set this aside for right now. That's going to come back in just a minute. But now we're going to solve this like we did before, treating this just pretty much like an equals. So we're going to minus the 4 over. So we minus the 4 over and get 3, and then we square both sides. Again, you could just have this as an equals right now. The inequality is irrelevant right now. We'll get to it in just a minute, but if you prefer to just write this as equals, it's significantly easier. 3x minus 6, so we add 6 to both sides. So 3x is less than 15, divide, and x is less than or equal to 5. All right, so here's our number line, and we have 2 and 5 are the 2 numbers that we've found. So we need to take some numbers to go ahead and test. So I need a number that's in this section, something that's less than 2. Well, 1 works. How about a number between 2 and 5? 4. Could you pick 3? Sure. Something greater than 5. How about 6? Real simple. We're going to test these 3 points. What's going to happen is, because of the inequality, we're going to get some shading in these different points. We might be less than 2, we might be between 2 and 5, or greater than 5. Now we are going to use these, that's where these inequalities will come in, so these will be closed, and we have to make sure that we write it as an inequality. But we're going to go ahead and test these different points. So let's go ahead and do that. So we do have to do this check. This is step 3. So we're going to do those points that we have. We have 1, 4, and 6. So when I plug 1 in, 3 times 1 minus 6 is negative 3. And negative 3 is a negative number. And so when you take the square root of it, it doesn't work. So if I'm going back to my number line here, I can just kind of X out this area here. We're not shading that in. This is not an area that we need or want. All right, because that's going to make imaginary numbers. So go ahead and try the 4. Put the 4 in. 3 times 4 is 12, minus 6 is 6. The square root of 6 plus 4 is 6.45, which is less than 7. Again, just do that in your calculator. That's fine. Get a decimal approximation, because we're just testing a point, and it's less than or equal to 7. So that middle section is one that we will like. So we definitely kind of want to like have this one filled in. X'd out that one. This one's going to get filled in. Let's see about the last section here. So we're going to try 6. Put 6 in. 3 times 6 is 18, minus 6 is 12. Square root of 12 plus 4 is 7.46, which is bigger than the 7. So that area is not good. So the only area we want is between 2 and 5. So we just write 2 is less than or equal to 5 is less than or equal to, 2 is less than or equal to x is just less than or equal to 5. All right. A lot of times it is going to be that middle section, but it won't always. So that's why we have to test. Let's try another one. All right. So again, I'm starting with whatever's inside the square root. So square root equals 0. Let's find out where that point is. Minus 5 Divide by 2, we get negative 5 halves. So that's my first number here, negative 5 halves. Then I'm going to actually solve this. I solve this by adding 2 over to 11. Again, notice I just went with an equals because it's just easier. Square both sides, 121 minus 5, divide by 2, x equals 58. So now I have my two areas here. And I need something in between them. Well, something in between them is 0. 0 is an awfully easy number to do. And negative 10 and 100. It doesn't have to be 59. Could you do 59? Sure. Why not do 100? Why not do negative 100 if you wanted to? I don't care. Just as long as it's in this section, middle section, and the top section. You want to do pi in here, go right ahead. Okay? I'm going to use some of the easier ones, 0, 100, negative 10. Just makes life easier. So let's test that. So starting with the negative 10, 2 times negative 10 plus 5 gives me negative 15. And when I go to take the square root of that, that's going to be no solution. See, that's part right here, the 2x plus 5. I started with that right away. So this top section here is just the square roots parts. So negative 15, I can't get a square root of a negative 15, so it's no solution. So this area is not good. Here I get 5, which is 2.24, about minus 2. That's going to be less than 9. That's good, yes. When I put in 100, I get 205, which is 14.3 minus 2. That's definitely not less than 9, so no. So again, I'm dealing with that middle section here. So go ahead and test whatever numbers you want. It's fine, and then write your answer accordingly. Again, it's less than or equal to because the original problem is less than or equal to. All right? That's what I have for you today.